Let me just a second. Can I see your homework, the last one? I need the data. It's the same thing, right?
Yes.
Today, can you see the clean white screen? Yes, thank you. Good. Okay. Today, for the first one, let me discuss the homework number 2. In homework number 2, I ask you to take the MSE. Which was the SSE over the degree of freedom, and the degree of freedom was the big N minus K. The big N was the total number of cases, and K was the number of groups, and SSE, I gave you the 2 equations for SSE. One was the double summation, basically. The double summation, double sum of square, right? It's a sum of square. But SSE was the within the inside, so individual minus the sample mean from each sample, right? And another way is it will be same as the single summation, but we need the degree of freedom from each sample, and we need the variance. We need the variance from the each sample, right? Always the outside, there is an index for I from 1 to K. So this one is the same summation for I from 1 to K. And the inside one is from 1 to, from the J, from 1 to NI, right? So today, we are going to discuss the homework number 2, and we are going to use this one to get the SSE, right? Sometimes we have the each variance from each sample, absolutely. We can use the second one, but now in homework number 2, I didn't give you the variance. So when you need the variance from each sample, is at least you have to take this summation. So today, I'm going to using the first one, the double summation. Okay, let me try. Let me try the number 1. In number 1, we have 4 samples. 4 sample group is a K is equal to 4. And now I have a 6, 3, 3, and 9, 5, 7, 8, 6. Let me take the each sample mean. So let me add up the 3 observations. 12. It's a 12 is over 3. That is a 4. So let me take the xi bars. That would be 4. And let me take another summation. It's 9, 5, 7, 8, 6. 35. Now divided by 5. So the second sample mean is a 7. And let me take another sum. It's a 4 and 4, 2 and 2, and 3. 15 divided by 5 again, and there is a 3. And 8, 4, 6, 18. But now divide by 3. So here's a 6 one. So we have the different 4 sample means from each sample, right? That is the xi bars. Then now we need the difference. We need the difference one. So I have to take the minus 4. That will be 2. Negative 4 minus 1, minus 1. But for 9, I have to subtract the 7, right? Because we have to subtract each sample mean. So now I have to take the minus 7. That will be positive 2. Minus 7 is a negative 2, 0, 1, and negative 1. This one for 4, we have to subtract 3. It's a negative 3 will be positive 1, positive 1. It's a negative 1, negative 1, and 0. And now here is a negative 6. It's a subtract 6. It's a 2, negative 2, and 0. You know, in this case, when you take the difference, always you can take the sum up. I mean the without the square. Just to sum up, always 0. That will be always, it must be the 0. The summation without square. Because that was one of the property when we took the variance is before, right? Because of that, we took the square. Okay, now let me take the square. So I didn't have a spaces over there. So let me take the space. It's come here. 4. I'm from here. It's a 2 square. 4. 1 and 1. 4. 4. 0. 1 and 1. Yeah. In the second sample. And 1 1 1 1 0 from the third one. And 4 4 0. So far, we take the difference and square. Now take the summation. Take the summation in each sample. And then what? It's a summation of the all samples. That means we just take the summation of the all squares differences. So now it will be 6. It will be 10, 4, 8. So it's actually the summation, the I from 1 to 4 is a k equal 4. That will be 10, 10, 28. What is the name of the value 28? SSE. Okay. So what did I do? Step 1, take each mean. Step 2, take the differences. I mean this one. And step 3, take the square. And how can I say it's 4, 5? As a step 4, it's a column wise in each sample. Take the sum, the inner summation, and 5, and sum up. That will be SSE. Any question? So now SSE is a 28. How many big N? Let me take the small ni's. Here's a 3. That is a sample size actually. 5, 5, and another 3. 16. 16 is the total number of cases. Minus, who was the K? Number of samples. Number of groups here. 1, 2, 3, 4. So MSE is the MSE will be 28 divided by 12. 28 divided by 12. I have a 2.33. It will be 2.33. So that is the MSE. I want to try the second one. I want to try the second one as well. Can I open the new one? Just a second. How can I erase all? Just delete and open again, maybe? Good, right? Let me try number 2. We have 5 groups in number 2. It is the 16.27. The second one is a K equal 5. And I have 7, 4, 5, 4. 7, 4, 5, and 4. N equal 4. 5, 9, 4. 5, 9, 4. 6, 7, 5. 6, 7, 5. And 4, 8. 3, 7, 7. 4 and 4. And the last sample, 7, 9, and 11. Again, we need the XI bars. So let me take the summation. 7, 4, 5, and 4. 20 divided by 4 will be 5. It's X. It is X1 bar. It is X1 bar, but generally, let me use the index of I. And the next one is a 5, 9, 4. 18 divided by 3 will be 6. And sample 3, 6, 7, 5, 4, 8 divided by 5, 6 again. 3, 7, 7, 4, and 4. 25 divided by 5 will be 5. And 7, 9, 11 is a 27 divided by 3 will be 9. It was 5 and 9. Okay, then what? We need the difference. Okay, so let me change the color. Minus 5. So 2, negative 1, 0, negative 1. What did I say? The sum of without square is must be 0. Good. Negative 1, 3, negative 2. 0 again. 0, 1, negative 1, negative 2, positive 2. 0. Negative 2, positive 2, 2, negative 1 and negative 1. 2, 4 and 4, yeah, 0. And negative 2, 0, positive 2, yeah, is another 0. Then now what? Take the square. Yeah, it is almost the same as take the variance because it's another formula. It's another formula using the SI square, the each variances. Yeah, it's almost the same as the variance. So now here, let me take the squares. So 2 square 4, negative 1 square is 1, 0, 1, 1, 9, 4, 0, 1, 1, 4 and 4, 4, 4, 4, 1 and 1, 4, 0 and 4. Then what? Double summation. That means it was the overall sum. Okay, so let me take the sum this way first. 6, 14, 10, 14, 8. Yeah, please let me know if I took the wrong value. Yeah, please compare your answers. And if you got is another answer, it's a different one, yeah, please let me know. Don't trust me. Then now 6, 14, 10, 14 again, and 8. The summation will be 52. Did you get 52? Anybody, please? Not yet? Did you? 52? Thank you. Good. Who is this? S. Oh. S-E. Thank you. S-S-E. And now we have to figure out is how many big N, and already we knew how many K, 5. So now let me take the sample size, Ni's. Here's a 4, 3, 5, 5, 3. So the big N, 20. Now the big N is 20, and K equal 5, and SSE was 52. So finally, MSE is 52. 20 minus 5 will be 15. So 52 over 15, it will be 3.47 MSE. You can try by yourself the third one. Any question? So do you have an idea? How can you get the MSE? So please complete the second homework, and please take a picture and email me today. And now, now I'm recording. Now I'm recording the collaborate, this section, what I'm doing, and I will give you the link again. Yeah. So now, yeah, this is my first time to using the collaborate. So, do you have a better idea or the better way to erase is everything? You know, I'm just to close it and open again, right? But probably there's some function. It's erase is everything, or the better function or better things. Yeah. So please, let me know if you know the better way. Yeah. Okay, then let me clear up and again open. Yeah. So let me summarize. Up to now, we discussed the MSTR, which was the SSTR over the degree of freedom. Always we have a sum of square is kind of the variance and divided by the degree of freedom. It was a between, so between degree of freedom would be k minus 1. Yeah. I can memorize the any formulas, but I do not just memorize. I'm trying to understand, right? Actually, the MSTR is a between, so we need the between sum of square, and also we need the between degree of freedom. Yeah, so it is easy to figure out is how many degree of freedom is between. It's between k samples, so k minus 1. And the MSE, that is the SSE over the big N minus K. Yeah, it is the same thing. Yep, let me give you the SSTR. SSTR is always a double summation. Yeah, again, it was the between, so between the sample mean variance. And another way, it is a single summation, is a Ni xi minus x bar square, because the inside one for j from 1 to ni and outside one from I from 1 to k. So here is the I 1 to k. And SSE is another double summation. I interpreted the MSE, SSTR is between the between groups, and MSE is inside, it's within groups, inside, within. So now we need the inside variation from individuals. So xij's minus xi bar square. Again, the inside one for j from 1 to ni, and outside one from I from 1 to k. And we can modify with the each variance, using the each variance, the summation, the each degree of freedom, and the variance in for I 1 to k. So always we have two kinds of the summations for the sum of squares, and simply divide by the degree of freedom, then we can take the mean squares. And now I give you the easier way to get the degree of freedom. The k minus 1 from how many xi bars? It's actually, it is a k, because the xi bars, the each sample mean from each sample. So it is the same number of the sample size, the samples, right? It's a k. And it is the overall mean. So we had only single value for x bar. So simply just take the difference, because we took the difference before. It's the same way. Now, what is the notation xi and j? Individual, right? It's each individual. How many? Big N. Because the big N was a summation of the small n's. It's a total number of individuals. Big N, yes. And now here is xi bars. How many? Yeah, it was a k. Then what? Subtract. So take the degree of freedom. It's very easy. It's how many the statistics, right? And just to take the difference. So that will be the degree of freedom. Okay. And also when we have a data structure, yeah, we have a data structure. It's like this way, right? It's a many samples. It's a 1, 2, 3, 4, 5. Yeah, it's a K like this way, right? It's inside. It's a this way. It's a vertical way. That will be MSE, the inside, right? but between, let me use a black one. It's a between groups. That is the MSTR. It's a between. And MSE is a within, inside. So please understand what is the meaning of the MSTR and MSE, and also how can we get them? The formulas. Yeah, it's these two with the degree of freedom. Okay, it's good. Any questions so far? Let me clear up. But as I told you, I will give you the link for the video I'm recording right now. So you can finish up. You cannot finish up yet the copy, my writing, and then you can see again. You can watch is later. So let me clear up. So please put some blank if you couldn't finish up the copy. Yes. Okay. And I need a. Okay. So now we are going to discuss how can we use them. Okay. So let me say again, what was the null hypothesis? It's always, I told you, is any kind of applications, we can apply the 5 steps. Always at the beginning, we have to state the null hypothesis. So we stated the null hypothesis is mu1 is equal to mu2 is equal to mu3. Yes, up to k. So we had population number 1, population number 2, population number 3, and k populations. These are population 1, population 2, population 3, and population k, right? And actually, we want to compare the single values from each population. Name the population mean. Population, I have to say, is means. So we want to compare them, right? In the second step, we took what? Test statistic, right? Let me see. One sample t-test, the test statistic was a t-score. X bar minus the mu zero from the null hypothesis divided by S over square root of n. In the pooled 2-sample t-test, the test statistic was a t-score, but it was defined as the mean difference. X1 bar is x1 bar minus x2 bar divided by SP times 1 over n1 plus 1 over n2, which was the t-score, the test statistic in the pooled t-test. Now we need the test statistic in ANOVA. Yeah, we are discussing the ANOVA here. It's our leaders. We compared as many population means, right? It will be a ratio of the two mean squares. Okay, so it will be MSTR over MSE. Before t-test, we use the t-distribution. Because of that, the name of the test statistic was the t, because we took the p-value from the t-distribution. Now we have to name it as f. Why do you think? We are going to discuss, we are going to take the probability from the f distribution. Okay, so because of, let me introduce you the f distribution today is later, but we are going to take the p-value from f distribution. It's another random variable. It's another distribution, but it can be defined from the fraction, the ratio, MSTR over MSE. Okay. Before, look at the f distribution, but let me think the other way. Now we have a sample. Actually, the test statistic is from the sample, right? Yeah, look at this. It's a sample means, SP from the sample variances, sample size. Basically the test statistic in any kind of applications from the sample, right? It's kind of the statistic, any kind of statistics from the sample, right? So now we have k samples. So here's sample 1, here's a sample 2, and here's a sample k. And we had k sample means. So here's we can take the x1 bar, x2 bar, xk bar. So because of that, the degree of freedom was the k minus 1 or big N minus k, because the k was the number of samples, and that is the same number of sample means, yeah, from each. Let me see. Consider MSTR again. What was the interpretation? What was the interpretation of the MSTR? The MS, the mean squares, was defined as the sum of square over the degree of freedom. I said that MS is a kind of the variance. Okay? So now I can say the F distribution, the F score, it is the fraction of the two variances. So another way, generally I can define the F distribution is a fraction of the two variances. It's a variance 1 and variance 2. It's basically we can define the F distribution is a fraction of the two variances. And now we have two mean squares, and the mean squares is kind of the variances. Yeah, it makes sense, right? But please focus on the MSTR. The MSTR is the variance, the between variances, right? So this way is a between the sample means. If I want, okay, is a later, in step number 3, we are going to take the p-value is later from the F distribution, and then we are going to make the decision, right? If I want to reject if I want to reject the null hypothesis, just a second, reject the null, reject the null. What does it mean? they are not same, right? If I want to consist, they are not same, what they have to do, what they have to be is a bigger variance. Is a bigger variance among the sample means or smaller variance among the sample means? Bigger, thank you, yes. If I want to reject the hypothesis, another way, if I want to say they are different enough, we need the bigger MSE. I'm sorry, bigger MSTR. Definitely, the F score is a fraction, it's a ratio. It depends on MSE. But if I put a constant, it's a fixed MSE, then simply we can expect we need a bigger F test statistic. Okay? Yes, it is true. We need a bigger F test statistic, then we can reject on our hypothesis. What will be the conclusion? They are not same. Does it make sense, right? Yeah. But always we have standard error. You know, the name of the denominator is any kind of the test statistic. The name of the denominator is a standard error, right? But what's the name of the denominator now in F? MSE. What is the E? Error. Yeah. So always we need the error term in the base, in the denominator. It's the same idea. MSE is another variance. 4. I interpret it as MSE is the within, the inside, within the variances, but it is the measure of the error. It is the measure of the error from inside. So relatively, the MSTR is bigger, or MSE, the error term is smaller, then absolutely we are going to take the bigger test statistic, the bigger F score, then we are going to reject the null hypothesis. Then how much do you expect the p-value when we have a bigger test statistic? Absolutely, I said we are going to reject the null hypothesis. That means the p-value must be less than alpha. Must be smaller. Must be getting smaller, the p-value. So fail to reject, you can apply the other way. The MSTR is getting smaller, MSE error term is getting bigger, then F test statistic is getting smaller, p-value is bigger, then alpha. Finally, we cannot reject the null hypothesis. Right? So please understand the relationships. It's MSTR, MSE, test statistic, p-value, decision. Everything is related to each other. Okay, yeah. And please compare to the picture. Okay, yeah, it makes sense. So please try to understand why we need the bigger F test statistic. If I want to say they are not same, yeah, we need the bigger MSTR. We need the bigger F score. Okay, so let me introduce you the F distribution now. So let me Google. Can you see the Google website, the Google homepage? No Google on my how about okay. I have to share my computer. Okay, how about now? Please say yes or no. Did you type? Yes, okay, let me go back. Okay, let me go to the Wikipedia for F distribution. Yeah, can you see the F distribution? The right column? Sometimes please look at the gray one. Can I write here? No. Yeah. So please look at the look at this. Yeah. The gray one. It looks like the bell shape. You know, sometimes the F distribution looks like the normal distribution. Yeah, even, but it's not always. Please look at the red one and the blue one here and the others. You know, basically, the F distribution is not symmetrical. And please look at the range. Always positive. Think about that. What was the definition of the F distribution? I told you the F distribution basically, oh my God, don't look at the formula. You know, basically, the F distribution is the fraction of the variances. I told you the F is basically the fraction of the two variances. What is the sign of the variance? Positive or negative? Or possibly both? Always positive. Always positive. Always positive. What do you expect? Positive, right? It's a positive over positive, always a positive, right? So it's a non-negative, but sometimes, yeah, it's like this one. And now, yeah, the parameter, you know, the normal distribution needed the two parameters, mean, location, variance or standard deviation for the size, right? And the t distribution needed only one parameter. It's named the degree of freedom, right? And the binomial distribution needed the two n number of trials, p probability of success, and the Poisson. Can you remember the Poisson distribution instead one? Poisson needed lambda, which was the mean. So each distribution, in each statistical distribution needs some parameters. F distribution needs the two parameters. You know, in the Wikipedia, it has the D1 and D2 because it is the degree of freedom 1 and degree of freedom 2. T distribution needs only one degree of freedom, but F distribution needs the two degree of freedom. Do you know why? Because we can take the degree freedom 1 from this variance, from the numerator, and the other one 2 from the denominator. So basically, the F distribution was defined the ratio of the two variances. So we can take the two degree of freedoms, right? So let me go back. Let me go back to, okay, is it clear up? So now let me go to the second step. F test statistic was MSTR and MSE. I told you we are going to take the p-value from F distribution. Generally, the F distribution is, I'm sorry, oh my God, where's the eraser? Oh, I got it. When I click this button, is it clear? Oh my God. Okay, let me try again. F was MSTR just a second. When I okay, anyway, MSTR over MSE is a F, is a non-symmetrical. Yet how smoothly, yeah, it's like this way. Okay, and always a positive. It's good. Then now we need the degree of freedom, the 2 degree of freedom. df1, as I told you, from the numerator, from the MSTR, and the other one, df2, from MSE. Can you remember how many degree of freedom in MSTR? MSTR was the between k minus 1. Between k samples. MSE within, inside, from each individual, from all individuals, big N minus K. Okay? So when I take the p-value, always we are going to take the right end. It will be the p-value. From the F distribution with the 2 degree of freedom. So if you have a calculator, TI-84, I have TI-N Spire, right? Okay, now let me share the screen again. And now I open the TI-84. Can you see my calculator on the screen, on your screen? Please say yes or no. Yes, okay, let me go back. When you go to the distribution, yeah, you have to go to the distribution. In your case, you can click the menu. If you have a TI-N Spire, then please click the menu. Then probability, number 5, probability, and there is a distribution. But if you have a TI-84, then you can go to the distribution, the blue letters. So it's a second distribution. And there is the number 1, 2, 3 for the normal distribution. Number 4 and 5, I mean in the TI-84, is the T distribution is up to 6. And number 7 is a chi-square. And please go down, go down, go down. Yes, here it is. Number 9 and number 10. Number 9 and number 0 is a F, C, D, F. We need the cumulative probability for the p-value. So always we need the F, C, D, F, and it asks us who is the lower and who is the upper and the 2 degree of freedoms, right? If the order is right. Now distribution F. Yes. My calculator asked me the lower bound, upper bound, numerator df, and denominator df, right? So we can plug in that order. So let me go back to the, I erase again. So let me share the blank whiteboard. So I told you we have F distribution, positive, it's non-symmetrical. And I told you always the right end will be the p-value. So when you take the probability, the right tail, then it must be the lower value and the upper, it must be positive infinity. So my case, I just plugged enoughly large values. I just plugged the 9,999. That is big enough. And then the 2 degree of freedoms, the numerator and the denominator is a df1, that will be k-1, the numerator from MSTR, and df2 will be big N minus k from MSE. Is good? So I want to stop the lecture today here, right? And now, after the class today, I will give you the homework number 3. What do you expect? You know the homework number 1, I ask you take the SSTR. You know, actually, that means simply divided by the k-1, then it will be MSTR. And homework number 2, at the beginning today, we discussed take the SSE and MSE. Now, in homework number 3, I will ask you take F, test statistic. Yeah, already you took. Yeah, when you finish up the homework number 2, then already you took the 2 MS. Then simply just to take the ratio to get F test statistic and p-value. You know the decision is nothing. Yeah, simply compare to alpha. Less than alpha, reject the null hypothesis. Not, yeah, fail to reject the null hypothesis. So we don't have to make the conclusion because even I didn't give you the alpha, but it will be very easy. So I will give you the homework number 3 today, and it will be due Thursday. Take the F ratio, the test statistic, and the p-value from your calculator. Okay, so I wanna stop the lecture here. So do you have any questions?
How do you determine what that lower limit is?
Oh, it is the F. I'm sorry. Oh, that is a good question. The lower, it is a test statistic. The lower is the test statistic. What is it? The F ratio. MSTR over MSE. Yes, yeah. You know before the T test, right? Yeah. You know, from the bell shape T. This one was the test statistic. Yes, yeah. It's almost the same idea. So the lower is must be the F test statistic. Okay, thanks for coming. It's a physical classroom and collaborate online. So let me stop the record.